So we are given three of these functions, L of x, m of x, and n of x. And they are plotted here, but we don't know which one's which. And they ask us which curve on the graph corresponds to which function equation. So why don't you pause this video and have a go at that before we go through it together. OK, so there's a couple of ways to approach it. But you can see that all of these are exponential functions. As x increases by an interval, we're multiplying by the same amount for every successive x. For example, if x is equal to 1, you're multiplying your initial value by 0.7. When x equals 2, you're multiplying that by 0.7 again, so on and so forth. So one way to think about it is, which one is going to be decreasing fastest and which is going to be decreasing the slowest? Well, the one that decreases the fastest is the one that's essentially multiplying by the smallest factor every time. And that right over here is n of x. As x increases by 1, you're essentially halving it every time. So n of x is going to be the one that decreases the fastest. So n of x is c. So this is n of x right over here is c. And we can even validate that. When x equals 1, we're going to take 0.5 times 175. When x equals 1, 0.5 times 175 is indeed 80, what is it? 87.5. So it's going to be, and that looks indeed right where it is. And similarly, which one's going to decrease the slowest? Well, that's m of x, because it's multiplying by 0.9, which is higher than 0.7. So the slowest declining one is m of x. So that is this right over here, m of x. And the one in the middle is L of x. And once again, you could try to validate it by substituting some numbers, but you just have to think about which one's declining the fastest and which one is declining the slowest.